Okay, here we're looking at thermal equilibrium, and this goes along with the zeroth law of thermodynamics, which says that if substance A is in equilibrium with substance B and substance B is in thermal equilibrium with substance C, then substance A and substance C are also in thermal equilibrium. And this is just saying that if you take substances of different temperatures and you put them together, they are going to either gain or lose energy, heat energy, until they are at the same temperature. Everything's trying to get toward that equilibrium. Okay, so the example problem here, if you place a 25-gram block of iron, so this is our block of iron, 20 m mass, 25 grams, at 85 degrees Celsius, our block of iron is Ti, initial temperature is 85 degrees Celsius, into 75 grams of water at 20 degrees Celsius. Here's our water, mass 75 grams, initial temperature 20 degrees Celsius. What will their final temperature be? So we're looking for TF. If this goes into this, what will their final temperature be? Okay, just as a review, Q is heat. Q represents heat, and the formula for Q is mass times specific heat times the change in temperature. The specific heat, if you watched that last video about calculating heat, every substance has a different specific heat. It's how much heat it takes to raise 1 gram of that substance 1 degree Celsius. So every substance has a different specific heat, and then the mass. Okay, so here we know that the heat gained by one substance is going to equal the heat lost. Or gained plus lost equals 0. But however much heat this water gains is going to be equal to the amount of heat energy that the iron lost. So we know the water is going to increase in temperature, so it's going to gain thermal energy. The iron is going to decrease in temperature, it's going to lose thermal energy. So here we have the heat energy of the water, mass of water, mCp delta T of water, because water is going to be the substance that gains temperature in this exchange. Set it equal to the Q mCp delta T of iron, because iron is the substance that is going to lose heat energy in this exchange. All right, so this little graph here, not graph, but image, is just a visualization of what's happening between the two substances. So on the left we have water, W, at 20 degrees Celsius, and on the right side we have our iron at 85 degrees Celsius, and when they're both put together, this one is going to lose heat, so it's going to lose, its temperature is going to drop heading this direction, and the water is going to gain heat, so its temperature is going to move this direction, going up. And somewhere in the middle, we will have a final temperature that both of the substances will be at. And I use this when we get down here to the final minus initial part, the delta T. So the water on the left, this is the substance that's gaining heat. We have mass 75 times Cp 4.186 times delta T. This substance is gaining temperature. So to find the difference in temperature, the difference here, we're going to take the final minus the initial, and that'll tell us how many degrees here of change. Set it equal to mass of iron, specific heat of iron, times the change in temperature of iron. Now this one, we're losing temperature, so it's going to be 85 minus the final temperature to find out what the change in degrees was here. So we have 85 minus TF. All right, just combine 75 and 4.186, combine 25 and 0.45. Then we are going to distribute the 313, distribute it to TF and negative 20 here. Distribute 11.25 to 85 and TF. Get here. And then just the algebra, add your whole number, and then subtract your number with your variable, move it to this side of the equation, and we land here. And then we just divide out 325.2, and we get a final temperature of 22.25 degrees Celsius. Now this final temperature, I would just want you guys to notice, 22.25 is way over here by water. So the water only gained a little bit of heat it only didn't gain a little bit of heat. It only increased a little bit of degrees Celsius, whereas the iron really lost a lot of temperature. And the reason why is the specific heat of water is much higher than the specific heat of iron. Water is one of the highest specific heats, one of the substances with the highest specific heat that we know of. It takes a whole lot of energy to change the temperature of water, and it can hold heat for a really long time also. So our final temperature is way over here, 22.25.